Hi, my name is Eric Garr, Area Sales Manager at Fortress Technology. Today I'm going to demonstrate the Interceptor DF Metal Detector. The Interceptor DF is designed to inspect low-profile products across any belt width. Examples of these types of products could be cookies, crackers, or even bulk product with a low burden height across the belt. The Interceptor DF targets flat contaminants with orientation effects such as foil or flakes. In some orientations, these contaminants can be almost impossible to detect using a traditional single-field metal detector. However, with the divergent secondary field of the DF, these contaminants become almost impossible to miss. Now, to demonstrate the performance of an Interceptor DF, we're going to use some spherical contaminants as our control to show that with or without the secondary field, those detect at about the same signal. What we have is a 0.8 millimeter ferrous sample, a 0.8 millimeter non-ferrous sample, and a 1.2 millimeter stainless steel sample. We're going to follow the run of our control with a run of a variety of aluminum and copper foil strips here. And what we're going to see is that they're very difficult with a single field, but with the divergent field activated, they become very easy to detect. So we'll run them on top of a cookie like so. And our non-ferrous sample will run through and it generates a signal of about 300. We're going to do now the non-ferrous sample. And it generates a signal of about 450. Now the stainless steel sample. Generates a signal similar to the non-ferrous at about 450. Now we're going to do the same thing using this aluminum foil sample. Clear the signal out. And it gave us a signal of 52, so not a detection because it did not exceed 100. Do the next copper foil sample. And we got a signal of 27. Let's reset the signal first. And we'll run a smaller sample of the aluminum foil. And we only got a signal of 5. Our last copper foil sample. And the signal did not even exceed 5. We're still at 5. So you can see, although our sensitivity is really good to the spherical contaminants, 0.8 and 1.2 millimeters is a very good sensitivity for a biscuit line. We do miss these contaminants that actually look quite large. Now we're going to change our product setting here. So this product setting runs both of the fields on. So now we have the single and divergent field running. First thing we'll do is we'll run our test spheres to show that it's running at about the same sensitivity. And then we'll see how it does with each of the foil contaminants. So first, 0.8 ferrous. Again, a signal of around 200 to 300. Our non-ferrous sample. Generates about 450 once again. And the 1.2 millimeter stainless steel. Again produces a signal of 450. Now we'll do the same thing and run the flat contaminants through, and we should see a substantial increase in their signal with respect to these test spheres. So first we'll run the larger aluminum foil sample through. Reset our signal. and we can't actually get a signal larger than that on this metal detector. So it's gone from undetectable to impossible to miss. Our second copper foil contaminant, reset the signal, and again went from undetectable to a signal close to 10,000. Foil sample number 3, aluminum foil, reset the signal again, and it generates a signal of 7,000. Last but not least, this last copper foil. And again, that didn't produce any signal last time, and now it generates a signal of 18,000 plus. So you can see the substantial improvement to these traditionally difficult to detect contaminants.